All right, so we're going to take a look at your performance final study guide. The way your performance final works is you have two sections. You see section 1, 2 pages, and then section 2, 2 pages. And what it is you have to choose one option from each section. Okay, so one option from section 1, one option from section 2. So in section 1, there are 2 pages. Either you're going to do A or you're going to do B, not both. If you write on both, I will mark it all wrong. Okay, so if you write on both, it's all wrong. You have to choose which question you prefer to do and do that question. Right, so if you mark it both, if you put markings on both, you're marking it all wrong. So you'll choose either A or B. So you'll do either this question or this question. And then in section 2, the same thing, you'll do either this question or this question. Because this is a study guide, I'm going to do all the questions because you're going to choose whichever questions that you want to do. So I'll go ahead and start off with this. And you might as well already pull up a calculator so that you know you have that ready to go when you need it, because why not? So again, pull up your calculators, desmos.com/practice. Please make sure this is the calculator that you're using. And then, of course, pick your state. So you choose your assessment. And whatever state you're in, start practice. Okay, so there's your calculator ready to go for this question. All right, so I'm going to go over all of them, but remember, you're only choosing one from each section. All right, so it says on a windy windy morning, a hot air balloon starts rising and falling away at the top of the hill. An altitude 18 feet of the ballooning hours started after starting its ascent from the hill can be modeled by this function. All right, so anytime something is happening, you always want to kind of have a picture of what's going on. And so that's what I'm going to do. So the hot air balloon starts rising and flying away. So here's a hot air balloon. Ooh. All right, so it's rising and flying away, and then here's the ground, right? That's what's happening. All right, the altitude, after starting its ascent from a hill. Oh, so here's a hill. So the ground is there, it starts from the hill. It can be modeled by this function here, okay? The question is, what is the y-intercept? So anytime you have a function, remember in standard form for quadratics, it's gonna look like a, b, oh, I'm sorry. It's gonna look like ax squared, this is in standard form, plus bx plus c, where c is your y-intercept. Okay, so that plus c is your y-intercept. So all you have to do is look at the equation and find it. So here's the equation. Here is my y-intercept. This is your starting point. So what is the y-intercept of the function? The y-intercept is equal to 14.07. And is it in feet? What is this in feet? So it starts the hill. What that means is that hill is 14.7 feet up. All right, so what is the y-intercept? What does the y-intercept represent given this situation? Okay, so I just answered that. All right, so I'm not gonna write it because it takes me forever to write it here, but I'm saying it out loud. It means the balloon started off 14.7 feet up. The hill was 14.7 feet tall or high, however you wanna write that, but that's what it is. Use the equation to explain how you find the answer. All right, so again, I've just said what the y-intercept means in this given situation. Use your equation to explain how you find your answer. So you would just say, again, right here, I'm saying it, but I'm not going to write it down because it's going to take me too long. A quadratic equation in standard form looks like, and then you write this down, right? Where C, and then you see how I've circled it, where C represents your y-intercept, which is equal to 14.7 feet. That's the explanation. When it says use the equation to explain how you found your answer. That's your explanation. All right, part B. There's a positive and negative x-intercept for this function. What is the positive x-intercept? Explain what the x-intercept represents in this situation. Show your work. Okay, so there are several ways that you can do this. Okay, so formula, find the roots of an equation is x equals, and this is a quadratic formula. They usually give it to you when you're doing questions, but it's b squared plus or minus 4a, hold on, no, negative b. Sorry, I'm trying to go off memory here. My bad. Negative b plus or minus, so this is x equals, which is the x-intercepts or the roots or the solutions, or there's one more, x-intercepts, roots, solutions, or I can't think of it right now. All right, plus or minus the square root of b squared minus 4ac over 2a. Now, because it's saying show your work, you have to show your work. But I'm going to show you how to use the calculator just to double check that your work is correct. Okay, but you can't just put it in the calculator and not show your work, because if you don't show your work, you don't get the credit. All right, so this is what that is. And then what you do is you take your regular equation. So your equation is negative 4.9 x squared plus 9.8 x plus 14.7. All right, and then you label A, B, and C. So whatever is next to the x squared, including the symbol, is A. Whatever is next to the x, including the symbol, is B. And whatever is by itself, including the symbol, is C. And all you're going to do is punch it into this calculator. So, into the formula. So it goes negative. Then every time I have, so remember how we're doing this, right? So I always say box there, plus or minus. So you copy the equation where there are variables with parentheses around them, blank, squared minus 4 blank blank, because that's where the variables are, right? Over 2, because that's a number, and then variable blank. So remember from before, you copy down the equation where the variables are, you put the blanks, and now you're just going to put the blanks in. So here is B, B is 9.8. So that's what you put in there. All right, here it's B again, so B is 9.8. Here it's A is negative 4.9. Here it's C, C is 14.7. And here it is A, and A is negative 4.9. All right, so this is you showing your work, okay? And then you're just gonna write down the answer. So X equals, and you're gonna use the calculator to do that. We're gonna type in exactly what I see all the way across, okay? So negative, parentheses, 9.8. And we're gonna first do plus, because you can't do both at the same time. The square root, you hit over here, square root of parentheses, 9.8, squared, shift 6, squared, come back down, minus 4, parentheses, parentheses. In that first one is minus 4.9. In that second one is 14.7. All right, you get 9.8. So my first one is 9.8 divided by, and then you come back, well, let's do this one first. 9.8. Actually, we'll just do the bottom. The bottom right here, 2 parentheses. Inside that parentheses, negative 4.9, which is negative 9.8. So negative 9.8. Or, so I did the first one with the plus, and I'm going to do with the minus. Now, instead of copying all of this down, I'm just going to copy, Control C, come on unite, paste, Control V. So copy, Control C, paste, Control V. And then I'm going to go change this right here, this plus to minus right before the square root. So right before the square root, that plus right there needs to be a minus. So that's my new answer. So this is negative 29.4 divided by, and the same bottom because nothing changed, right? So negative 9.8. All right, so then X equals, and now we're just going to put that in the calculator. So the first one was 9.8 divided by negative 9.8. Okay, negative 1. So X is negative 1, or X is, the second one was negative 29.4 divided by negative 9.8, positive 3. Okay, so this is how you are showing your work, okay? This is how you're showing your work for what the x-intercepts is. Now, notice you have 2 x-intercepts, right? But the question says, what is the positive, okay? So my final answer, I would write x is equal to 3. That's my final answer. Make sure you write that one because they're not asking you for both. They're asking you for the positive. That's me showing my work. Now it says, explain what this x-intercept represents given the situation. Okay, now you can, again, I'm going to say this in words, but you're going to write it down in your explanation. So here is the hot air balloon. Okay, it rises and it falls. Okay, this right here is 3. Okay, this right here is 3. Okay, so what does that mean? Sorry, this is not feet. This is in time, which is in hours. Okay, so hold on. Hours. Okay, because your x is time and y. Look at it this way. This is your x and this is y. So y is height in feet, and this is time in hours. Okay, so what does this mean? In words, I would draw this picture and I would say the x-intercept represents the time it took the hot air balloon to rise and then fall, and it's the time that it hit the ground. So your x-intercept represents the time it took the hot air balloon to come all the way back down. Okay, that's what it is. So you're writing that in words. I'm not writing it because it's too much right there. Okay, all right. And then do we have a part C? Part C, what is the maximum height in feet? Okay, so what is the maximum height that it reaches? What is it up here? Show your work. Okay, so show your work. All right, so maximum height is going to be minus b over 2a. So remember, my b was 9.8. So you go minus, and so let's go ahead and put this parenthesis 2 and then parentheses. So my b was, let me just make sure, AB. Yeah, my B was 9.8 and my A is negative 4.9. Okay. All right, then stick that in the calculator. Negative 9.8 over 2. Oh, I'm sorry. Did that wrong. Let's just keep it in. Let's keep the parentheses in there. All right, so negative 9.8 divided by 2 parentheses, and inside that is negative 4.9. So 1. So 1. What is the maximum height in feet? Actually, that's not right. Oh, I'm just not finished. That's what it is. So this is your X value. So this is the time. This is in hour. This is the hour. This is the time it takes to get to your maximum height. So it's 1 hour. So what you have to do is plug it back into your equation. So where you see X, you're going to put this 1 hour. So it's negative 4.9, since you have to show your work, negative 4.9, 1 hour squared plus 9.8. You're just rewriting the equation with the X being 1 plus 14.7, since you want the height. So this is the time it takes to reach that maximum height, and this is the actual, going to be the actual height. And you're just going to stick that into the calculator. So negative 4.9 parentheses 1 shift 6 squared plus 9.8 parentheses, oops, parentheses 1 plus 14.7. All right, so that maximum height happens at 19.6 feet. All right, so the question says, what's the maximum height in feet the balloon will reach? Show your work. So right here, 19.6 feet. Here's my work on how to find it. The balloon will reach a maximum height after how many hours? All right, so I've already done it here, and you can just do this. You can do an arrow right there, and then just write in here after 1 hour. Okay, and here's the work for it. And that's it. So that's the first one done. Okay, so if you figure that one's easier for you, do that one. If not, this is your second option. All right, so the second question. The second question, it shows populations of bacteria increase at exponential rates. Okay, so this is an exponential on the table, an exponential on the graph. It says which bacteria sample A or B has a smaller initial population, what is that value? All right, so when you're looking at exponential functions, all functions on exponentials are written in A, B raised to the X. Okay, so that's an exponential function. So let's find out at what point, and okay, so remember, this represents, sometimes there's also another one here. So let me put it this way. A plus C represents your initial. And usually if there's nothing here, it's just A. And then B represents your growth. And I apologize for my writing, or decay. Okay. All right, so what we're going to do is we're going to put this in the calculator, because why not? Let me see what it asks. It doesn't ask me anything about showing my work. Okay, great. So I'm just going to put this in the calculator. Put a table in the calculator. Remember the plus sign, table. Put in your values, 0, 1, 2, 3, 4. Y is 70, 350, 1750, 8750, 43, 750. All right, once you put it in the table, write down your exponential equation. So y sub 1. So remember, anytime we put it in the decimals calculator, it has y and x has to have that sub 1 part. Squiggly line instead of the equal sign. And then it's AB raised to the x. So AB raised shift 6 to the x. And remember, anytime you put in the x, it has to be sub 1. So anytime you put y or x, has to be sub 1. And boom, it gives you your A and it gives you your B. So my equation for this function is y equals 75 and then x. And you can check that, right? Because look, if I put it in here, so if I do 70 parentheses 5 raised to the x, right? That means whatever I raise the x to, so let me check 2 and see if I get 1750. So if I put this in parentheses over here. If I put 2, do I get 1750? Yes. If I put 3, do I get 8750? Yes. If I put 4, do I get 43,000? Yep, I do. If I put 1, do I get 350? Yes. If I put 0, do I get 70? Yes. So this is my equation for this table. Now the questions ask which bacteria sample A has a smaller initial population. What was that value? All right, so which one? So my initial, so remember when you're looking at a function, your initial is going to be your A. So this one is a 70. And really, what does that mean? It means when x is equal to 0, what is your y value? Because when no time has passed, what is your y value? So my initial for this one, for AX, is 70. My initial for the graph, oh look, it's right here, 75. Or you can look at the graph. It's where it crosses the y-axis, but I can't really tell what that number is. So I'm just going to go off this number right there. So this one is 75. This one is 70. And the question is, which bacteria, A or B, has a smaller initial value? Okay, so it's going to be A. So I would say A. And then what is that value? So I would say initial value, and excuse my handwriting, equals 70. So I've answered that first part. Okay, right. Then compare the population of each sample on the 7th week. Which sample was larger and by how much? Okay, so the 7th week, right? So I have 2 equations here. I have this one right here, and I have this one right here. Now, if I go to the graph, does it show me 7? It doesn't show me 7, and this one doesn't tell me 7 either. So I'm just going to use both the equations. I'm going to erase all of this because I don't need any of this, and I'm going to put both of these equations in here. So y equals my first equation, 70, and then 5 raised shift 6 to the x. And then my second equation the same thing, except this is 75 and this is 4. So I put both equations. Green is my first one and purple is my second one. Okay. Now that I have both my equations there, I can answer all these questions. Compare the population to a sample of the 7th week. So over here, I need it to be the 7th week. So X is 7. This one, X is 7. All right, compare them, which sample is larger and by how much. So which number is bigger? So this is 3 right there, 3 right there, 3 right there, 3 right there. So this is 5.4 million. This is 1.2 million. So which one is larger? This one is larger. So I would say A is larger. By how much? So I would do 5.4 million, all of these numbers. 5 minus the other number. Okay, so can I just copy and paste this number? So copy, paste, yay. Okay, so it doesn't do it exact. That number minus this number is that number. So 4239950. So by 4.2 million roughly. Okay. Assume there's a third population of bacteria that grows according to the following function. So now there's a third one, right? So let me go back here and put my x's back. And now there's a third function, so I'll make my third one. So this is A, B, and this is going to be C. And this one is 475. And over here we have 1.0765. Okay. All right, so that's my third function. Okay. What is the percentage growth of the third population? What is the percentage growth of the third population? So remember, we talked about this number plus if there's a number over here is your initial, and then here is your growth and your decay. If your number is bigger than 1, it is growth. If it's between 0 and 1, it's decay. So this is my growth right here, and now I need to find the percentage. Okay, so if you remember from your notes, when you're calculating the growth, you do 1 plus the decimal, okay, times 100. So now we're going to go backwards and subtract it. So it's going to be 1 minus, subtract the 1, the decimal will be 0.765. And to turn that to a percent, I'm sorry, you're going to multiply by 100. And you can just put that in the calculator or move this 2 decimal places. So this is 76.5%. And I'm sorry, I misspoke because I should have said this is divided by 100. So usually when you're given the growth, you first thing you do is you turn into a decimal by dividing by 100, and then so you divide by 100, and then depending if it told you it's growth or decay, if it's growth, you do 1 plus that number. If it's decay, you do 1 minus that number. So this will be 76.5, and you'd put this part. You don't need to put that part. So I guess I do need to put 1 minus 1.0765 minus 1. So put this part right there. So you just subtract 1 from it. So it'll give you the decimal times it by 100. That's your percent. So my percent is 76.5%. Right? How much bacteria would you expect in the third population after 3 months? So that's 12 weeks. So find out in this X, what is it they give you? Okay. Everything is going per week, the population exponential grade. Yeah, everything is in weeks. Okay, cool. So now they're asking in 3 months, which is 12 weeks. So you come up here and we're gonna make the time 12. And that is your answer. So to show your work, what you do is you'd write this part in here, like what you put in the calculator. So write all of that in there, and then you'll say how much bacteria. So roughly round to the nearest 10th. So you'd say final answer to the nearest 10th is, that doesn't do anything. So 1150.4. Okay. All right. And that brings you to the end of the first section. So you're choosing section from that section, you're either doing the quadratic one, this one, or you're doing the exponential. Okay, now you come to the second question. Okay, you're going to either do this one or this one. But since this is a study guide, I'll go through each and every one of them. All right. The table shows different functions, so f, g, and x. Which of these represent linear? All right, so linear, remember, you're adding or subtracting to get the next number. So let's see if that's what it is here. From here to here, we're subtracting 2. 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 Okay, this one is linear because it's changing at that same constant rate every time. So f of x is linear. And again, I'm not going to write this, but I would say copy this part right here in this box and say it's linear because, again, write it down, right? It's linear because it is changing by -2 each time. It's changing at a constant rate of -2 each time. Okay, so write that there. That's how I know f of x is linear. Which of these functions represents a quadratic? Okay, so quadratic. So if I know f of x is already linear, now I'm looking for a quadratic. It's between these two. Quadratic, the second difference is constant. Okay, the second difference is constant. I'm gonna do this one first and then come for that last one because I already can tell this quadratic and this exponential. But let me do, actually, I'll just do it. I'll do this one and then I'll tell you why I know if this one is quadratic. All right, so again, this is how you show your work. So the answer is h of x, and this is how I know. All right, quadratic, you find the second difference has to be constant. So what's the difference? How do I get from 19 to 6? I'm gonna subtract 13. And again, if you can't do that in your head, you just do it right here. 19 minus 6 is 13. So I'm going down, right? So I'm subtracting 13. So if I check it, 19 minus 13, do I get 6? Yes, I do. All right, then from here to here, I'm still going down, so I'm subtracting. From here to here, I'm still subtracting. From here to here, I'm still subtracting. So what's the difference between 6 and -3 is going to be 9. So again, you do, if you want to do it in the calculator, it's the second number minus the first number. So -3 minus 6, -9. The next one will be -8 minus -3, -5. If you're using the calculator. And then the last one will be -9 minus -8, -1. And then just check your numbers to make sure it's right. All right, you can see these are not the same, so it's not linear, but quadratic says the second time I do this, the second difference is constant. So how do I get from -13 to -9? Well, from -13 to -9, I'm going in the positive direction, so it's plus something. But again, you can just punch it in the calculator. It's always the second number minus the first number. So second number is -9 minus -13. I'm adding 4. All right, and now I'm just going to check. Each time do I add 4? So I'm at -9 plus 4. I get -5. You see that happens. Plus 4, I get -1. So that works. So it's plus 4 plus 4. So this is for quadratic. You'd say h of x. You would put this work in here, okay? And then you would write, so write down, it's quadratic because the second difference is constant. This is the first time I do the difference. This is the second time. All right, so it's quadratic because the second difference is constant. All right, so you put this work there and say that. All right, last one. How do I know it's exponential? All right, so exponential is multiplication, okay? What do you multiply to get to the next number? So to find out, so g of x would be the answer, it's the only one left, right? And then you would do this work. So it's multiplication, so you do second number divided by the first number. So 0.5. So what that is saying, if I'm multiplying by 0.5 every time, it's exponential. So how do I get from one number to the next? So I'll start with 64 times 0.5. Oop, not 0.5, 0.5. Boom, 32. If I multiply by 0.5, I should get 16. Yep, if I multiply by 0.5 again, I should get 8. And if I multiply by 0.5 again, I should get 4. Because every single time I'm multiplying by 0.5. So again, you'd copy this work in that box. So copy this part right here in this box, and you say, so now you write it down, right? So g of x is exponential because you multiply by a constant number each time, rate each time. So you can multiply by a constant 0.5 every time, something along those lines. It's exponential because you're multiplying by 0.5 every time. Okay. All right. And then, so that's A, B, and C. What's the average rate of change for function f of x over the interval, and explain your answer? So anytime you see average rate of change, remember it's slope, right? So it's going to be y2 minus y1 over x2 minus x1. So rate of change is always anytime you see rate of change, it's slope. When it's not linear, okay, you call it average rate of change. So slope. All right, so remember I want box minus box. This should be nothing new, over box minus box. All right, then I want you to label. So this is x1, x2. So I want to find y1, y2. So when x1 is 4, what's y1? So let's go look. When x1, which function are we looking? F of x. When x1 is, I forgot, -4. -4, the first function is 16. So that's going to be 16. Okay. So when x1 is -4, f of x is 16. When x2 is -2, f of x is -2, f of x is 12. All right, and then you just put them in the box. So the first box should be y2. y2 is 12, so you put 12 right there. y1 is the next one, so y1 is 16. Put that right there. x2 is the next one. x2 is -2. x1 is -4. And then you let the calculator do your work for you. So I'll put in the top and then I'll put in the bottom. So on the top, just like I see it, exactly how I see it, -4. On the bottom, exactly how I see it. I don't care that there are two negatives next to each other. -2 minus -4. Exactly what here. Write it all down. +2. All right, then put that in the calculator. -4, exactly as I see, divided by, which is a slash sign, 2. -2. Boom. Done. Okay, so that's how you do that one. So that one's actually, I would encourage you to do that one. That one seemed easy and fast. However, if you don't want to do that one, you can definitely do this one. So this one says 150 children in summer camp have signed up for swimming. There's a total of 62 children to sign up for canoeing, 28 also signed up for swimming. Construct a two-way frequency table to summarize the data. All right, so two-way swimming and canoeing. So this is swimming, people swimming. This is no swimming. This is people canoeing. This is no canoeing. There are 150 children in the summer camp. So that's the total number of kids. That's total. All the totals is 150. 71 signed up for swimming. So 71 signed up for swimming. I don't know, if they signed up for canoeing, but I know they signed up for swimming. There were a total of 62 children that signed up for canoeing. Okay, 62 children signed up for canoeing, but it doesn't say anything about swimming, right? And it says, and 28 of them also signed up for swimming. So out of this 62, 28 of them also signed up for swimming. All right, then you look for where you have two values. Okay, so I see that I have two values here, which means I can figure out what goes in here. So this plus this gives me my total. So if I'm going backwards, I can do 71 minus 28, and that will give me the number that goes in here, which is 43. Okay, so I look for two numbers. I have two numbers here, right? Because I don't have two numbers anywhere else. So I can find this. This plus this will give me 150. So going backwards, 150 minus 62 will give me 88. Again, I'm still looking for two numbers. Okay, I have two numbers all the way across. So this plus this gives me this, so I can go backwards, and I can do that all the way down. So 62 minus 28 gives me that number there, and I can do 88 minus this number to get this one. 88 minus 43, and the last one I can do 150 minus 71. So I'm just going to write those numbers in. So this one is 34, 45, and 79. And I can double check these numbers to make sure they work, because I know 34 plus 45 must be 79. 34 plus 45. Yep. 28 plus 43 has to be 71. 62 plus 88 has to be 150. And then you can check them across as well, but I'm not gonna do that at this time. All right, so after you check them, what percent of students who have gone canoeing did not go swimming? What percent of students who went canoeing did not go swimming? So you look at what percent of students going canoeing, who have gone canoeing. So the people who've gone canoeing, right here. Okay. What percent of students who've done that, okay, did not go swimming? So out of these, which ones did not go swimming? 34 of them. So 34 out of the total of 62 who went canoeing did not go swimming. And you just put that in the calculator. So 34 divided by 62, and then you multiply by 100 to make it into a percent, is 54.8, because the nearest tenth, that doesn't do anything. So this is 54.8. All right, part C, the class president concluded, that there's a correlation between those who go swimming and those who go canoeing. Do you agree with the class president? Explain your thinking. All right, so it says those who what? Those who go swimming, so those who go swimming and those who go canoeing. Swimming. Those who go swimming and go canoeing, and what is the correlation? Like, are they related to one another? Okay, in some way.